Hello everybody, welcome to this video 13 section 5 lecture 1 continuation of the previous class of subnetting class B. Now we are going to borrow 7 bits. So when we borrow 7 bits, as per the formula, number of networks is equal to 2 to the power 7, which is 128. Then we get the number of hosts per subnet, which is 2 power 9 minus 2, that is 512 minus 2, 510. Because there are totally 16 bits, 16 minus 7 is 9. Magic number, 7 bits have been borrowed, so the first 7 bits are all ones and the 8th bit is 0. So this gives us a magic number of 254 in the third octet. We are still in the third octet. Now block size is 256 minus magic number, so that is 2. And we get a new subnet mask by substituting this 254 in the interesting octet, which is the third octet. Now block size of 2 means the next network will be 2. The first network is 0, the second network is 2, and that is in the third octet. So third network will be 2 plus 2 4, then 4 plus 2 6, and so on and so forth. So in the third octet, 0, 2, 4, 6, 8 all the way to 52 to 54. So these are how many? 128. So 128 networks. Now 510 hosts per subnet. Let us try to find out that. The second subnet minus 1 will give us the first subnet's broadcast address. So 2.0 minus 1 is 1.255. So these are the valid host present in this particular network. If we count from 0.1 through 0.255, that will be 255, and then 172.16.1.0, that is a valid IPv4 address in this particular subnet. So 0.255 is also a host, 1.0 is also a host. Otherwise this would be the one of them would be the broadcast, another would be the network. So this is the case where we see that 255 is not a broadcast and 1.0 is also not a network. Rather these two are valid IPv4 addresses. So and for this 1.0 subnet, if we consider 1.0, okay, then there will be 254. So 254 over here, and then the 0.255 and 1.0. So those two will be added, and that is how we get 510. So 254 plus 254 is 508, and then those two addresses. Likewise, remaining subnets also have 510 valid hosts in their subnets. So sometimes you are asked a question, 172.16.0.255, is it a valid host, or it is a broadcast, or it is a network, or what? So we have to find the particular subnet. So based on the subnet, we can decide whether it is broadcast or it is valid IPv4 address, whether it is a network or it is a valid IPv4 address. Sometimes we just don't think, we say 255, okay, so this is broadcast, and we look at it something .0, 1.0, 2.0, so it is network. No, that is not the case. This is a perfect example for that. Now when we borrow 8 bits, then it becomes /24. It is like class C default subnet, but in class C default subnet there is only one single subnet, but in class B when we borrow 8 bits, it is 255.255.255.0, the subnet mask, which is same as class C default subnet. But over here we have got 256 different subnets, because these are the borrowed bits. For class B, the default subnet mask is 255.255.0.0. So we got this 255 by borrowing 8 bits. That is why we get number of networks as 256, and for 16 minus 8 is 8. So we have got 8 host bits. So accordingly the number of hosts would be 254. Block size is 1. So when block size is 1, we get more number of networks. So if first one is 0.0, second will be 1.0, then 2.0, 3.0. Let us see. Remember block size is 1. So 0.0, 1.0, 2.0 all the way to 255.0. So if we count from 0 through to 55, these are 256. So we get 256 networks. Now 1.0 minus 1 will be 0.255. So this is the valid host range, valid host addresses. 0.1 through 0.254 would be 254 hosts. And this is the subnet mask for each of this particular subnet. So this is not that difficult. /24 does not necessarily mean it is class C default. So /24 could be for class B or it could be for class A as well. For class C there would be a single subnet. For class B and class C, if it is /24, for class B there will be 256 networks. For class A there would be 2 to the power 16, 65,536 networks. Now case 6, borrow 9 bits. So when I borrow 9 bits, my interesting octet is in the 4th octet, because class B 8 bits means 3rd octet and 9th bit means 4th octet. So in the 4th octet the magic number is 128. That is why the next subnet will be 256 minus this 128, which is 128. So this gives us the block size, remember. So block size of 128 means what? Block size of 128 means in the zeros network we will have 0.0, 0.128. Then in the ones network 1.0, 1.128. Let us see. So block size is 128, 0.0, 0.128, 1.0, 1.128. Likewise 255.0, 255.128. So 0 series has got 2 subnets, 1 series has got 2 subnets. So from 0 through 255 we have got 256. So each of these 256 they have got 2 different subnets. So 256 times is 512. So we get 512 different subnets. Now let us see the number of hosts. So this address -1, so that will be 0.127. So this is the broadcast. So one more than the network is the first host, one less than the broadcast is the last host. From 1 through 126 we have 126 valid hosts. So this calculation is not that difficult. All that we need is little bit of concentration, and then do those calculations thoroughly with the help of our notebook and the pen. So still I always emphasize, keep a notebook and pen and do these calculations by yourself. Just by looking at it you can only understand the things, but if you want to remember them for a long term, please keep on writing them and practicing again and again. So what happens when I borrow 10 bits? So 6 bits are also already there. Sorry, 8 bits are already there. This is class B. Sorry, 16 bits are already there. 16 plus 10, 26. So 26 means which octet? The 4th octet. So 25, 26. So 2 bits. 2 bits would be borrowed in the 4th octet. So 2 bits means 192. So the subnet mask would be 192 in the 4th octet, and then block size would be 256 minus 192, that will give us 64. So 64 is the block size, and then the hosts per network would be, what is the total number of host bits? So 32 minus 16, so that will be 6. 2 power 6 is 64. 64 minus 2 is 62. So keep on doing these calculations. The more you do, the more you understand, and quicker you will be able to do. So please go through this, take any subnet from private class and then practice it. And if you have any doubts, please raise your queries in the QA session so that I can clarify all your doubts. So keep continuing, keep your practice with this, borrowing more and more number of bits. Let us have a summary of subnetting class B. So default is /16. As we increase the number of network bits, what happens? The number of subnets increases and the number of hosts per subnet decreases. So if we want only 2 hosts, we always use /30, be it class C or class B or class A. So for 2 hosts we use /30, for up to 6 hosts we use /29, for up to 14 hosts we use /28. So these numbers will give you the idea based on number of hosts what should be the subnet mask we need to use, and this column will tell us based on the number of networks that are required in your organization what should be the subnet mask that you need to use. So if you have somewhat 500 subnets, then we use this particular from class B. That should be all about class B subnetting. So please make sure that you write them so that you will understand it. And once again, I would like to request you, whatever queries you have, please don't hesitate to ask in the question answer session. I'll be back with all those answers, all or doubts to clarify your queries. Thank you very much. See you in the next class. Bye for now.